Okay, this is Leetcode 3168, minimum number of chairs in a waiting room. So we're given a string s, and we're given some constraints here. If s of I equals e, a person enters the waiting room and takes one of the chairs in it. And if s of I equals l, a person leaves the waiting room, freeing up a chair. And we're tasked with returning the minimum number of chairs needed so that a chair is available for every person who enters the waiting room, given that it is initially empty. So given that it's initially empty, this tells us that we need to start with an E. We can never start the string off with an L, which will help simplify our code later. And the reason behind that is because if the room is initially empty, a person can't leave the waiting room because there's 0 people in the waiting room at that time. So we know we can start with an E. Now for the basic intuition of the problem, we're going to have a variable that we're going to initialize to 0 we'll call it current count. We'll initialize that to 0. And I'm going to loop through the string. And at each point, we're going to increment or decrement the current count variable as needed, whether we land on an E or an L. And this should show you how we can come up with the minimum number of chairs needed, because the max of this current count at a given interval of time will tell us how many chairs we need in the room. So we start off at E. We know we can increment the current count by 1 at E. As we go to L, we know we can decrement it. E, we can increment it. And then we can decrement it again with L. Now we reach the point where we can increment it. And then we can increment it again. Now we're at 2. And we can decrement it. And now we're done with the string. So what you might have noticed is at each point here, at each interval, and I is a time interval second. So at each interval, we can see how many chairs at the maximum are needed. So that will allow us to have another variable and store another variable, and we'll call this max count. And when we go through our loop, we're going to compare this max count with the current count. And at each point, we should be able to see what the max count is, or what the current count is, and how that relates to the max count. And at the end, we can just return the max count. So pretty straightforward. Let's go jump into the code. So here's the coding solution. We're going to initialize a max count, and we're going to initialize that to 0. We're going to have a cur count, which we will initialize to 0. Now what we're going to do is we're going to loop through for each character in the string. And first what we'll check is if the character equals E, we know we can increment this cur count by 1. And then what we need to do is we need to compare this cur count with the current max. And then the next thing we can just say is else if, so we're basically saying is if the character equals L, we know we can just decrement it. And at this point, all we need to now do is return the max count. Let's run this on the example. That works. Let's submit it. Accepted. Okay, now for the C++ solution. So same thing. We're going to initialize the max count to an integer 0, and then we're going to initialize the cur count to 0. Now what we're going to do is we're going to loop through. When int I equals 0, we're going to keep the loop going while I is less than s dot the length of the string, and we're going to increment I. And same check where if s of I equals e here, we know we need to increment cur count by 1. And C++ we can just do. And we know we need to then compare this cur count with the max count. So what we can do is standard library functions max count with the cur count, and we'll store this in the max count. And finally, our else condition, which if we land on this, we know we land on L, we know we can just decrement it. So cur count minus minus. Now at the end here, we know we can just return the max count. And we'll run this, works on that, and accept it. Okay, last part, we will go over the time complexity here. So for the time complexity, we are looping through the characters in S, and each operation inside here is an O of 1 time operation. So that leaves our time complexity to be O of n, where n equals the number of characters in S, because we need to go through each character in S and check and perform some of these O of 1 operations on each character. So that means the time complexity will be O of n. Now, the space complexity will just be O of 1. And the reason for that is all we're really storing here is the max count and the cur count. And these don't change given a really big S or a really small s. These are what are called constant variables. So all we're storing is constant space. And there you have it.